Sir has completed his post-graduation and diploma in CDAC from Pune ACTS. Sir has around more than 6 years of experience in C, C++, Python, and core Java. We are glad that on a very short invitation, Sir has accepted to be with all of us today and share some of his knowledge here. I welcome you again, Sir. With the power of technical mastery, Sir is currently on a mission to help more and more number of career aspirants. On behalf of Department of Electronics and Communication Engineering, New Horizon, and on behalf of our head of the department, Dr. Sanjeev Sharma, Sir, we welcome you, Sir, to the session. So students, please be attentive and try to grab whatever information Sir is giving to all of us here today. I hand over the session to Ganesha, Sir, now. Sir, here to you.
What is the time of duration of the session? Can you tell me?
Sir, it is 3 to 4, but if extended another 15-20 minutes also no problem, because this is the last hour class the students are having today.
Okay, okay.
Thank you, sir.
Okay, thank you, ma'am. Okay, so good afternoon, friends. Good afternoon, students. So I think all students are from the second year. So who are from second year? Just type me in chat box. Who are from second year? Just type me in chat box first. Then we'll start the session. Today's topic is the linked list. We're going to explore the linked list part. So just type me in chat box. Okay, you should be attentive. So whatever I am giving you some assignments or any message, you have to reply me. Just type me in chat box and let's see how many replies I'm receiving. I'm not receiving any reply. I'm not starting my session until you respond me. Yes. Uma Devi, Vinayak. Ankur, Avinash, Chandana, Gayatri, Gaurav, Harshita, Asvita. Yeah, I know Harshita and Asvita. Kuldeep, Janvi, Aishwarya.
Sir, Gayatri ma'am is also with us here today.
Yes.
So,
yes, everyone is from the 6th semester. Yes.
correct, sir. 6th semester.
6th semester means I think third year.
Third year.
Okay, okay. So you have the data structure subject in I think the second year, huh?
Sir, for till last year we had data structure as a separate subject. From this semester onwards, we have a common subject. Title is Programming with Data Structure and OOPS. So they'll be studying the theory concepts of both this.
Both this. Okay, okay. So actually, when actually there is this topic, should we are deciding the topic for this webinar. Actually you are demanding the subject as a OOP, okay, object oriented programming. But I insist that rather than giving that OOP, just take this topic linked list, because this topic never been explored in the one of the webinar. Always they are taking the advanced topic, but I'm always focusing on the basic thing. Okay, and what basic things we are focusing? We're focusing on a C language, because we don't know, if you don't know the C language, then there is no meaning of learning the C++ and learning the object-oriented programming. How the structure works, if you don't know how the structure works, what is the use of structure and why we write the structure, what are the advantage of structure, what are the disadvantage of structure, if you don't know, then there is no meaning of using the class in object-oriented programming. So that's why firstly, in a linked list, we are going to explore the how to use the structure kind of thing. Okay, structure is one of the data types. It is a user defined data type. Okay, it is a user defined data type in C language. So how to define the structure. What are the elements of structure? First we will see, and then after that we will use that structure in a linked list. What is linked list, what is array, we're going to see. Okay, so I think most of you has already studied that data structure. So any one of you tell me what is array? What do you mean by array? So array is, yes, participants. This is not a one way. Okay, this is not a simplex communication, that is I'm only transmitting and you are only receiving. This should be the full duplex communication. So whatever the question I'm asking actually, and you can mute yourself also. You can unmute yourself. You can unmute yourself. You can tell me the answer. Okay, Nita says data stored in a continuous memory location. Yes. Ankush says array is a collection of items stored at a continuous memory location. Yes, correct. Collection of data, group of element with a similar data items. Yes, collection of data with the same data item. Okay, so that is the two important things regarding to the array. First one is it contains the similar data items. It contains similar data item. If you are declaring the array of integers, all are integers. That is the very first thing to be remembered with the array. And the second one is the it is a continuous memory. It is continuous memory. So it means that if your array is having the 5 integers, all the integers are kept one after the another, one after the another. Okay, so it is a continuous memory block. Okay, so whenever you declare the array, whenever you declare the array, the very first requirement is there should be having a continuous memory. If your computer is not having the continuous memory of that particular bytes, then the array failed. Okay, the array get failed. You are not when you are allocating the memory for the array, and if the memory continuous memory is not there, then that your program get failed. So how to resolve this? Actually, generally you are creating the array of 10 bytes only, or 15 bytes only, or 20 bytes only, or 100 bytes, maximum 100 bytes. But 100 bytes easily get available. 100 bytes get easily available. But for example, if you want to store the data of the Aadhaar card, okay, if you want to store the data of Aadhaar card number, only you have to store the Aadhaar card numbers, whatever the available Aadhaar card. For example, 100 crores of Aadhaar cards are available. 100 crores of Aadhaar card available in India. So what data structure you prefer? You prefer the array? If you prefer the array to store the Aadhaar card number of 100 crore Aadhaar card number, then how many amount of bytes you require? Okay, how many amounts of bytes? Because to store the Aadhaar card number, actually we prefer we should use the double data type. We should use double data type or long integer. Simple long integer. If you are using a long integer, then the size of the long integer is 4 byte. So 4 byte for storing the one Aadhaar card, and 100 crores Aadhaar cards are there. So 100 crore multiplied by the 4, that is 400 crores of data bytes, and that should be a continuous memory. Okay, that should be a continuous block we require, and that is not possible because if you talk about the earlier computers, like the computer having a very less RAM memory, the memory size of your computer is only in terms of the kilobytes or in terms of the megabytes only. Okay, so when I bought my first computer, actually in my computer the RAM of my computer is 128 MB. 128 MB is my memory, RAM memory of my computer. So at that time, actually the memory very much matter, very much matter. And there again, the continuous memory block, if you are searching, then there is very less chances to get that very long memory block. So what is the solution? What is the solution of this problem? If I don't want to be store my variables in a continuous block, then what is the solution? The solution is rather than storing your data in the array, use the linked list. Use the linked list. So what is linked list? Linked list is, you can compare the linked list with the array. Okay, you can compare the simply with the array, like The array contains the homogeneous data items. Your linked list also contains the homogeneous data items. Yes, the linked list also contains the homogeneous data items. So if your node, the linked list contains the different nodes. Okay, so one node is having the same data item. Say the another node is having the again the same data items. Okay, so linked list is a collection of the homogeneous data items. But the second, actually the second thing that is true for the linked list, that is it is stored in a continuous memory. It is not true for the linked list. The linked list nodes are stored in a your discontinued manner. It is not stored in a continuous manner. It is stored in a discontinued manner. It means that it is actually get connected, but it is not the continuous memory. It is connected, but it is not a continuous memory. Just like you can take an example of railway. Okay, the first railway engine is there, and you can attach the first bogie to that railway engine. Then the first bogie, after the first bogie there is a second bogie, then the third bogie, then fourth bogie, then fifth bogie. Suppose the in between, suppose if your railway is having the 10 bogie with the engine, and if you want to replace that sixth bogie, then you can easily replace. You just have to detach it, and you are putting in the new bogie inside it. Or otherwise, if you want to attach the new bogie, then you can attach to the starting also, you can attach to the ending also. But it is not the case of the array. It is not the case of array. So if you declare the size of array, it is fixed. It is fixed. So if you declare the array size as a 10 integer, then it is always having the size of 10 integer. So your array is not dynamic. You can't increase the size of array, or even you can't decrease the size of array. But not case of the linked list. In a linked list, actually, we can change the size of the array anytime. We can change. So we always start the linked list with a zero node. So that's called as a null linked list, null linked list. So empty list. Okay, so we'll always start the linked list with the empty. Then we will attach the first node. Then we will attach the second node. Then we will attach the third node. Then we will attach the fourth node. Okay, we will create the linked list. Then whatever the operation that we want to perform on that linked list, we can perform. Like we can insert some items, we can delete some item, we can insert at the beginning, we insert at the last. But that advantage, you know that what is the advantage? We can grow that particular linked list exponentially. Why? Because actually we don't require the continuous memory block there. Just what amount of continuous memory block we require? The memory block that is required to allocate the memory for one of the node, and we are creating that node using the structure. Okay, so the structure is your node is made with the structure. So we'll create it. We are creating the node. Then we are attaching the second node to it. We are attaching the third node to it. We are attaching the fourth node to it, and we will expand that linked list. Okay, until we have all the data to be stored into that linked list. Getting the so very first advantage of the linked list is first advantage of linked list is actually we can grow the linked list exponentially. So that is we can go there is no such a limit that your linked list is having such a limitation, only 100 nodes, 200 nodes, any number of nodes we can connect here. Okay, so we'll first discuss about the what is the difference. Okay, so we already have been discussed some difference. So very first difference, array is a collection of element with a similar data items, and the linked list is a collection of objects known as a node, where node consists of two parts, data and the address. Okay, so here every node consists of the two parts, data part and the address part. So what this address part contains? The address part contains the address of the next node. Okay, so it means that if you are on a one node, and if you want to go to the next node, that particular node is having the address of next node. You cannot directly jump to the second node, you cannot directly jump to the third node, as we can do with the array. We can access the any particular items of the array using its index, because there is a indexing is there. Index start with the 0, so 0 to their size -1. Okay, so you can directly read any item, but it is not in the case of linked list. We should always start with the first node. then we are using the first node, we go to the second node. Using the second node, we are go to the third node. Using the third node, we are going to the fourth node. This actually, this operation is called a traversing. Okay, we are traversing from first node to the last node. Okay, the second difference is the array element stored in a continuous memory location. Yes, we know that continuous memory location. To store the array, we require the continuous memory block, but the linked list element can be stored anywhere in the memory and in a random storage. Okay, random store. So anywhere in the memory. So one block can have the memory address as a 1000. Second node can have the memory address as a 2000. Third block can have the memory address as a 5000. Okay, so anywhere in a memory where the memory is there, we can store our node, and then we can connect that node by using that address part of your particular node. Now, array works with a static memory. Here, the static memory means that the memory size is fixed and cannot be changed as at the runtime. So once you have declared the size of the array, it is fixed. You can't be increase, or you cannot be decrease the size of the array. So it is fixed at a runtime. It is fixed at runtime. But a linked list is called as a dynamic list. Linked list is called as a dynamic list or dynamic array. So linked list works with a dynamic memory. So here the dynamic memory means that the memory size can be changed at a runtime according to a requirement. Suppose if I want to store the data, we will dynamically allocate the memory and we will attach that particular node to the linked list. So dynamically we can increase the list of the we can increase the linked list. So the size of the linked list here is, it is not fixed. We can increase the linked list, we can decrease the linked list dynamically. Now the next difference is array elements are independent of each other. It is independent of each other. First item is not dependent on second. Second item is not depends on, so there is no dependency because every item is having its own index. Okay, it's having its own index. But here in a linked list, actually all items are dependent on each other. For example, the first node is depends on second node is depends on first, second node is depends on first. It means that to access the second node, we must have the access to the of the first node. So if you have the access of the previous node, then only we can access the next node. So that is a dependency. The next difference is array takes more time while performing any operation like insertion or deletion. Actually, we can't do insertion and deletion on the array, but we can actually we can do it by assigning the all the elements in a second array. We can create the another array and we will copy that first element of the array into the second one with the deletion or the insertion. Okay, so but it is having some time consuming because we have to create the memory, we have to copy all the elements, so it is time consuming. But here the linked list takes the less time while performing any operation like insertion or deletion. Why? Because suppose if the fifth node I want to delete, then what we need to do, we have to just adjust the links. Okay, we have to adjust the links. So fourth node link is now pointing to the sixth node. If the fourth node is pointing to the sixth node, then you can delete the fifth node. So you have to just adjust the links of the linked list. So it takes the less time while performing the operation like insertion and deletion. Now accessing any element in an array is faster than as the element in an array can be directly accessed through index. Yes, the array, if you are using, accessing any element is faster than the linked list. Why? Because every element is having its own index. So if you know the index, you can directly access it. Okay, but here in a linked list, actually we have to traverse. We have to traverse from first node to the that particular node, because we always know the address of first node. We always know the address of, we have the always the address of first node only. And suppose if I want to access the 100th element, then we have to traverse it. How? First to second, second to third, third to fourth, fourth to fifth, like that. So from first to 99th we have traversed, and from 99 to 100 node we are getting that particular node and we are accessing its information. Getting this? So it is time consuming. Accessing an element is, so linked list is having its own advantage and disadvantage. Array is also having its own advantage and disadvantage. Okay, in the case of the array, memory is allocated at compile time. Actually, when we create the array, what we do, int arr, and in a square bracket we are doing giving some size like int arr and in the square bracket 10. So here this is the known as a compile time memory allocation. But in case of the linked list, we are always using the dynamic allocation. So it is allocated at runtime. So generally we are using the malloc function to create the memory for the node in a linked list. Okay, the next difference is the memory utilization is insufficient in an array. For example, if the size of array is 6 and if the array we are storing only 3 elements inside it, then the remaining space is unused. Okay, so actually that is a major problem of using the array. For example, you are taking the test of your class. The strength of your class is 200, and suppose you allocate the memory for 200 students. So your all 200 blocks are there, but the test, the student, only the 60 students are attending that test. Only 60 students are attending the test. So what happened here, you have allocate the memory for 200 students, but only 60 has attempted the that particular test. So how many marks get generated? Only the marks for the 60 students. So 140 blocks get unused there. So you can see that it is a wastage of memory. Okay, but here the memory in a linked list, actually the memory utilization is efficient in the case of the linked list, as the memory can be allocated and deallocated at the runtime according to a requirement. So what happened in a linked list, whenever we need the block, we will create that block. So there is no memory wastage. So you can actually save the memory in terms of the linked list. Actually, one more difference is there. Actually, there is a memory overhead in case of the linked list also. Why memory overhead? Because in a first difference, it is says that the node consists of data and address. So but we are, the important one is data and address is not important. Actually we are storing the extra information into that particular node. So this, you can see that it is a memory overhead. Your user don't want that particular 4 bytes of the memory for every storing every address get wastage there. But we can actually save that memory from the last point. Okay, so it means that memory utilization is efficient here. Whenever we need the node, we create the node. Whenever we have actually use that node and we don't want that particular node anywhere, so we can delete that particular node. So efficient memory management we can do using the linked list. Yes, are you getting this? Okay, so we'll move towards the next topic, and that is the linked list. So what is the linked list? So linked list is a sequence of data structure which is connected to each other. So it is a linked list. As the name indicates, actually it is a list which is linked to each other, which is linked to each other. If the data items are linked to each other, then you can say that that is my linked list. So it is a sequence of data structure in which all the nodes are connected via links. So what is link? Link is nothing but the address of the next data or address of the next node, So here one more definition is node. What is node? Node contains the data plus address of next node. Data plus address of next node. Data plus address. If your node, if you want to create the node, then that node contains the whatever the data items you want to store. That data items can be anything. Okay, it can be integer, it can be a structure itself. The data items can be anything. So whatever the information you want to store inside this node, that is your data items. And one more point is there. There is a your node should have one pointer which is pointing to the node, which is pointing to the next node. Always remember that. So Here linked list is the second most used data structure after array. Yes, it is, because it is mostly used in a operating system design, and one of the complex data structure you can only create by using the linked list. Okay, so how to create the node? The node can be created by using the structure. Node can be created by using the structure. So just create a structure in which give the data items and give one of the pointer. Give the pointer which contains, which is pointing to the node, which pointing to the same node. Okay, now how this linked list can be represented? The linked list can be represented by like this. Okay, so here there is a head node is there. Head node contains the address of the first node. Okay, head node, or it is called as a start node, or it is called as a begin node. Okay, so there are several names of this head node. So head node contain, or head node, actually it is not a node, actually it is a pointer. So head is a pointer which is pointing to the first node always. So if I have the head pointer, I can go to the first node. Okay, if I have the head pointer, I can go to the first node. Okay, using the first node, I can go to the second node. Using the second node, I can go to the third node, because first node contains the address of the next node, second node contains the address of the third node. Now third node to fourth node, actually we can't go, because what is the next pointer of the third node? The next pointer of the third node is the null pointer. So you can say that here, if my next address of my node is null, there is no address is given for the next pointer, there is no pointing, the next pointer is not pointing to any node, if it is contains null, then that particular node is called as a last node or the end node. Getting this? So this first node, that is this one, this is called the first node, and the node which is having the next pointer as a null, this is called as a end node. It is called as a end node. Getting this? So how to create? First create the pointer, create the node, attach this link, and attach all the links, and you will get that particular linked list. So what are the different types of linked list? These are the famous types only. The first type is the singly linked list, or also called as a simple linked list. Okay, generally it's called as singly linked list. Singly linked list means we can traverse in a forward direction only. So from left to right we can traverse. We can traverse from left to right in a forward direction only. From head to end we can only traverse. Traversing means visiting from head to first, first to second, second to third, third to fourth, like that. Okay, this is called as singly linked list, or otherwise we can say that if your node contains only one address field, then that type of the linked list is called as a singly linked list. Okay, so how to identify if your node contains only single address part, then that is called as a singly linked list or the simple linked list. So we can navigate only from forward direction. Okay, second type is called as a doubly linked list. Now the name doubly linked list as represent, we can traverse from forward, we can again we can traverse from reverse. Okay, forward traversing also possible, reverse traversing is also possible. How to traverse forward and how to traverse reverse? If you want to traverse in a forward direction, actually this next should be present, yes, it is having next. But to traverse from reverse, actually again we should have one next part, associated with the node. So in a doubly linked list, actually what the node consists of, the node consists of data item and the two address field. Data items and the two address field. The data items, your information, what is the information you want to store, and the two address field, one field store the address of next node, and the another address field store the address of previous node. So using the address of forward and backward, actually we can traverse in a both direction. Okay, now circular linked list, the next type is the circular linked list. Circular linked list is again same. Here in a single linked list, what happened, the last node is indicated by the next field of the last node is null. This is a single linked list.
But if in your linked list, if the last node is pointing to the first node, if the last node is pointing to the first node, then it is, you can say that here it is in a circular manner. Sorry. So from first you can go to third, second you can go to third, and now third is having the address of first. So from say third you can again go to first, again from first to second, second to third, third to first. So it is actually, you can traverse like a circulary, you can traverse like a circular. So that's why it's called a circular linked list. So last item contains the link of the first element as the next, and the first element has the link to the last element as the previous. Okay, so this is in case of circular doubly linked list. Actually there are two types of circular linked list: circular singly linked list and circular doubly linked list. Okay, so these are the types of the linked list. Now these are some basic operation we can perform on linked list: insertion, deletion, display, search, and delay. So without waiting for this one, we will try directly going to implement the linked list. So what we can do, we will implement the linked list by using the C language. Okay, you can implement the linked list using C++ also, you can implement the linked list using Java also. So what I'm doing, okay, so which compiler you are using generally? Tell me which compiler you are using to uh, compile a C program. Tell me, just type your compiler name in a chat box. Chandra Mohan, yes.
Code block, sir.
Code block, yes, code block. Code block means GCC actually. Code block uses GCC compiler. So you are using GCC compiler. Okay, so here also I'm using the GCC compiler. First we can do our compiler is working or not. Always do the same thing. Whenever you going to start the first program of the C language on your computer, always do the very first program, that is a hello world program. So what is a hello world program? We are doing the hello world program with the hash include stdio.h, okay, and then int main, and then we are doing the printf hello world. Okay, so this is my program /n. Okay, so here I'm saving my program, Control S. So I'm saving my program like hello.c. okay, hello.c. So it is already there, so I'm replacing it. Now I want to compile it. Okay, I want to compile it. So for compilation, I'm going to the terminal. So just open the terminal. Now what is this? This is called as an editor. Okay, I'm using the Sublime text editor because it is very easy to use. So, and again it is having some colorful format. That's why for typing the program, I'm using the editor as a Sublime text. And then for compiling your program, I'm using the GCC. Okay, terminal. Okay, so how to do? My program gets stored in downloads. So I'm having the program inside the download folders. Now I want to compile that program. So how to compile? The compilation is again easy: gcc and then hello.c. gcc hello.c. Okay, the command is gcc hello.c. I'm pressing the enter. Now there is no error, so it means that my program gets successfully compiled. And then I'm using a./a.out. So when you are using ./a.out, your program get running. So whatever the instruction that you have written into a program, it gets start displaying your output. Okay, so it print hello world. So it means that the program get correctly running. Okay, so and also the compiler is also running. Okay, now next one is what is the task? The task of the today's is create a, we want to create a singly linked list. We're going to create a singly linked list. Okay, so to create a singly linked list, we'll start with the very first line as a hash include stdio.h, and then we are creating one structure. Okay, struct. Okay, structure. Okay, so what is the name of the structure? The name of the structure is node. Okay, n is capital. You can give the all the node as a capital also, but here the name of my node is node. Okay, name of my node is node. You can give the another name also. Okay, but struct node is the name of my node. So what the node contains? The node of the single linked list contains the very first one is the data part. So what the data part? I am storing the integer data. Okay, so it is the integer data. So here for simplicity, I'm taking only integer, but as per your requirement, actually, if you are you can store the any data inside the node. Okay, for simplicity, I'm taking only one integer data. Okay, now the data part is over. Now what is the next part? What is the next part your node contains? The node should contain the address part. So what is the address part? The address part is the pointer. We should create a pointer because the next part, the next pointer should hold the address of next node. It should hold the address of next node. So you should create here the pointer. So what is the data type of that pointer? Data type of the pointer is the it stored the address of next node. So data type should be the node pointer. The data type should be the type of the node. Okay, struct node is the data type of that pointer. So here this is my pointer and the name of the pointer is next. The name of the pointer is next. So here I have created the node which contains the data and which contains the address part. So here the pointer is created. Now I want that head pointer. I want the head pointer. So how to create head pointer? So I'm creating the head pointer like this. Struct node star struct node star head. Struct node star head. Okay, so this is my head pointer. Head pointer is created. So here it means that your computer is only having the head with you. So this is my head. Okay, this is my head and this is the pointer actually. Okay, this is the pointer. This is the head pointer. This is the pointer. It doesn't contains the data. It doesn't contains the address field. Okay, it can hold the address of node only. It can hold the address of the node only. Okay, so next one is I want to create a linked list. Simply one linked list I want to create, in which I can store the 10 first data as a 10, second data as a 20, and third data as a 30. Okay, so we'll create a linked list which is having the three node 10, 20, and 30. So how to create? So firstly, to store this 10, we must create one of the node. I mean, what we have to do? We have to create a node. Okay, so how we have to create the node? We have to create the node. So this is my node. Now this node contains the two parts. The node contains two parts. The first part is the data part, and the second part contains the next part. Okay, second part contains the next part. So I want to create this node. So how to create this node? To create the node, I need a pointer because the node should be created dynamically. The node should be created as a dynamically. So how to create the node? Simple. First create the pointer. So I'm using the ptr. Okay, node star ptr. And to create this node, now here only the ptr is created. Only the ptr get created. I can represent as ptr here. So this is my ptr. Yeah, this is my ptr. Ptr is simply a pointer. This ptr is head, like a head. Ptr is also the pointer which can hold the address of node. Okay, now next one is I want to allocate the memory. For node. So can you tell me, which is the function that is used to allocate the memory for node? Yes, anyone from participant? What is the function that is used to allocate the memory? Yes, Manideep, Kuldeep, yes, malloc, yes, correct. So we should use the malloc function. Okay, the malloc function actually need how much byte of memory you require. So here I should give here size of the struct node. Okay, I should allocate the memory. which is equal to the size of the struct node. Whatever the data, whatever the bytes required for the struct node, that is the size of my allocated memory. Okay, and but we know that the malloc returns the void pointer. So to convert that void pointer into our node pointer, we should typecast it. So I have typecasted it to the struct node star. So ptr is now equal to this. Now it means that here what happened here, now ptr is pointing to this node. Ptr is pointing to this node. So you can say here, if the address of this node is 2000, now what the ptr contains, what the ptr contains, the ptr contains 2000, ptr contains 2000. So it means that ptr is pointing to this. Okay, so actually this node is now the node I have not attached to the head pointer. Okay, the node I have not attached to the head pointer. I have to attach it, but before attaching I should fill its data. So how to fill the data? This 10 value, I have to store here. The 10 value I have to store in a data field of this node. Data field of nodes. How to do? Can anybody tell me how to store the 10 value into the data field of the node? Yes, anyone? Yes, anyone? Simply use the arrow operator, using the arrow operator. So ptr of data is equal to 10. Simple. Okay, because what is data? Data is an integer part. So ptr of data, we are accessing the data part of ptr. So using ptr I am accessing the memory and I am accessing the data part. So now this data contains, 10. The data contains 10. Now what is the next field? What should be the next field? The next field should contain the null pointer, because if it is only the one node present, if this is only the one node present in your linked list, the next of that particular node should always contain the null. So what should I specify here? null. Okay. So ptr of next is equal to null. Ptr of next equal to null. So here I can specify here my next is equal to null. My next is equal to null. But actually it is not linked list. It is not linked list. Where from the linked list start? The linked list start from head. But head doesn't contain anything. Head doesn't contain anything. Actually, you should initialize the head always with null. You should initialize the head always with null. So here, this is my head. Head contains null. So this is the scenario actually. Now what I need to do here, I have to attach this first node to the head node. So how to attach to this node to the first node? Very simple. Head is equal to ptr. Head is equal to ptr. When I do this head is equal to ptr, actually what happens? What is ptr? Ptr contains 2000. So whatever the content of ptr get copied into the head. So what happened here? The null get erased, and now the head contains 2000. Head contains 2000. So you can say that here now head is now pointing to this node. Head is now pointing to this node. Now this node is pointed by two pointers here, head pointer as well as the ptr pointer. Getting this? So until here, until now, actually your linked list is only having the one data item. Linked list only having the one data items. Now I want to add the second data item. So how to add the second data items? If you want to add the second data items, simple, just create a new node. Okay, create a new node. So how to create a new node? I'm creating the new node. Suppose there is again a pointer I'm creating, star temp. Okay, temp is the another pointer. So what I'm doing, temp is equal to struct node star, and then again malloc, and then again size of struct node, done. So temp is created. Now fill the data in temp. So temp of data is equal to 20. Okay, and then temp of next. Temp of next, what is temp of next? Temp of next is always filled with null. We will attach it later. Okay, we will attach it later, but create the temp node first. So here graphically also I'm creating that temp node. So this is my temp node. This is my temp node. Here it is created. Okay, the data I have filled with the 20. Data I am filled with the 20, and the next field is filled with the null. The next field is filled with the null. So this, the first one is data, second one is the next part. Okay, now it is not attached because our linked list start with the head. Linked list start with the head, and now this is pointed by the temp. Sorry, undo. This pointed by the temp. The temp is pointing this particular node. Okay, now we have to attach it. We have to attach. How to attach? If I want to attach, then how to attach? If you want to attach, simple, ptr of next or the head of next. Ptr of next or head of next both are same. Ptr of next is equal to, yes, if you want to attach, what you need to do? You need to remove this null, and if the address of this particular node, new node, is suppose 3000, so you have to fill this 3000 here. When you fill the 3000 here, you can see that here now this list is attached. This list is attached. Here is attached to first node. First node is attached to second node now. So how to do this? If I want to do this, then very simple. You have to do the same ptr of next. This field I have to fill with the 3000, but where the 3000 stored? The 3000 gets stored in temp. So temp is pointing to the particular node. So temp contains the address of that node. So whatever the address stored into the temp gets stored into the ptr of next. So ptr of next. So done. So ptr of next is equal to temp. Now this is get done. So now my linked list is having the two data. Linked list is having the two data. Like that, you can also, and you can modify that ptr. So ptr is equal to temp. Now ptr is pointing to the next. Now this ptr I'm doing ptr is equal to temp. The meaning is now ptr is also pointing to temp. Ptr is also pointing to temp. So I have advances that ptr. Why? Because I need the address of the last pointer also, because whatever the new data items I'm adding into the linked list, I'm always adding at the last. So the ptr always hold the address of the last data last node. So again, do the same thing. I want to add one more data items. So what I'm doing, I'm just copy this and I'll just paste this, because the same things I have to repeat. If I want to repeat the same thing, just I'm doing 30, because temp is now pointing to the next node. Now third node is created. Third node is created. Here third node is created, which is having the data as well as the address field. Now what I'm doing, temp of data equal to 30. So its data contains 30, and temp of next is equal to null. Temp of next is equal to null, so it contains null. It contains null. And then what I'm doing, ptr. Now ptr is now, and I can do this now. Temp, firstly, temp is pointing to the next node. Temp is pointing to the next node. This is the first step. Temp is pointing to the new node. Now temp of data is 30. Temp of next is equal to null. Now what is the next statement? Ptr of next is equal to temp. So what is ptr? Ptr is pointing to the second node. Now ptr of next is this one, this field. Ptr of next is equal to temp. So whatever the temp contains, it get copied into the ptr of next. So what happened here? This null get erased. The null get erased. And if the address of the next node is suppose 4000, this 4000 get place here, 4000 get place here, and you can say that now second node is attached to the third node. So like that you can repeat the statement, you can repeat this statement again and again and again and again. So this is, you can say that if I want to add one more thing, one more, just you have to copy this and you have to again paste it, you have to paste it again. And now temp of data is 40. Yes, you have to just replace this temp of data. So this is the repeated statement, these are the repeated statement. We can put this statement in a loop, we can put this statement in a loop, we can develop a program in which these statements are in a loop, and we'll ask to the user that how many data items you want, and if the user has says 4, then the loop will rotate for 4 times. Okay, so here the simple manually I have done, I am not using the loop. So your linked list contains 10, 20, 30 and 40. Now we will traverse that particular list, we will traverse. Okay, so how to traverse? Okay, my linked list is completed, my linked list is completed. Now I want to print the data of linked list. So how to do? I have to traverse, I have to traverse from head to last, I have to traverse from head to last. So what I'm doing, I'm doing temp is equal to head. What I'm doing, temp is equal to head. Now temp, this pointer, now this temp pointer is pointing to the head pointer, the temp pointer is pointing to the head. This is my temp, so temp is pointing to the head. Okay, now next what you need to do, now you have to forward this temp until you got temp as a null. If you get the temp as null, because you are doing temp is equal to temp of next, temp is equal to temp of next, and whenever you are getting that temp is equal to null, that is the last node, until that you have to print the data part of that particular temp, because the particular node you are accessing using the temp. So what is my statement? My statement becomes, we have to traverse while temp becomes null. Until the temp becomes null, you have to print the data part. Okay, so how to print the data part? Very simple. %d, and I'm doing here like this, and then how to access the data part? Simple, temp of data, the temp of data. In this way we can access that particular data part, and the temp should be forwarded to next temp. So temp is equal to temp of next. Now first time the temp is pointing to this node, now next time the temp is pointing to the next node, next time temp is pointing to the next node, temp is pointing to the next node, until you get the temp is not equal to null. Okay, when you are getting temp is equal to null, just you are not just you have to end this particular loop. Okay, so this is the program, very simple program. What we have done, we have stored the 4 values inside my linked list and we have traversed it, we have traversed. So just we'll check that this program is, what is the output of that program. So what I'm doing, gcc hello.c. Okay, so malloc function, for malloc function I should include std.h. For malloc function I need to use stdlib.h. Okay, so there is no error. So /a.out, and you can see here, firstly I have added, then I have printed. So 10, 20, 30 and 40. So this is my creation of the linked list as well as the traversing of the linked list. Yes, any question? Have you tried this before? Yes, any question from your side? So what is the, actually this is the very easiest thing actually. Just you need to first remember what is the meaning of temp is equal to head. What is the meaning of temp is equal to temp of next? Temp is equal to temp of next means you are forwarding that pointer. Now the pointer is pointing to the first node, next time pointer is pointing to the next node, next time pointer is pointing to the next of that next node, like that. Yes, if you know this particular thing, then linked list is a very easiest thing in the world, and you can develop a very long program here also. And again, what you can do, you can develop a certain functions, actually create function, insert function, deletion function, insert at the beginning, delete from the beginning. Okay, like that, the different function you can do, and you can design a menu driven program in which you can store the multiple items. You can store the multiple item in linked list, and you can perform the any operation. Search linked list is also one of the operations. Search linked list, for example, 10, 20, 30, 40s are there, and if I want to search that the 30 is present in my linked list or not, then I can easily do. What we need to do, we have to traverse from first to last, and we have to check that data. If the data is there, if the data matches with our key, then my linked list is having that particular data. Otherwise, if you go to the end part and there is no data is available, then you can give the message as there is no search key is available. Yes, getting this? Okay, so this is the very simplest things that I have covered here. You can actually implement the more complex thing than this. You can take the help of my previous lectures available on my YouTube. So here I'm sharing the my YouTube channel link. You can subscribe my YouTube channel. So we will have the question and answer sessions. So if you have any questions, then you can ask me, yes, regarding to the linked list. Any question, basic question. Yes, any questions? Indrajit, Reshma, Ankit. Yes, no, no questions. Okay, so as ma'am has told me that we should specify some certification program to you. Okay, so what are the different certification program is available with me? I will be sharing that with you. The very first certification program is the simply the master in C language. Okay, or it's called as a programming in C. So programming in C, this is the first program. Yes, sir, where do we use linked list? Okay, Chandramohan question asked the question where, sir, where do we use linked list? Okay, so generally the linked list is used. I have used. Okay, generally I have used the linked list while designing the different softwares. Like suppose we want to track the mouse event. If I want to track the mouse event, or if I want to track the keyboard event, what are the different keyboards uh, entry I have been done, or the mouse events I have been done. For example, I have designed a paint application. Okay, in that paint application, firstly I have developed, I have drawn the line. Whatever the coordinates of that line, I'm storing into the my first node of my linked list. Then after the first node, the second node contains, suppose in the second time I have drawn the rectangle. Okay, I have drawn the rectangle, then I have drawn the suppose circle. So first one is line, second one is the rectangle, and third one is the circle. So there is a this data, whatever this data I'm storing into that linked list. And when the actually windows get called as a refresh, then this particular items get drawn on your screen. Like first one is a line, second one is your rectangle, and third is the circle, like that. So just like, for example, if you are done anything, or if you are type anything, if you type your name my name, so GANESH. So when I type G, actually G get captured and it is get stored into the node. A get captured, A gets stored into the node. Like Q, like Q can be also implemented using linked list. Okay, stack can be also implemented using linked list. So whenever we require the sequential storage, there we can use the linked list, sequential storage. But the problem is where that list should be a dynamic. If you don't know how many entries are going to enter, for example, how many numbers you are going to type. Suppose you want to type your name. So suppose my name is Om. There are only two words. So if my name is Ganesh, GANESH, 6 words, 6 letters, like that. If you are Krishna Murthy, lots of words, lots of letters. So like that, if you don't know what amount of that particular, what is the size of that list, there we can use the linked list. Okay, or the application is the data where we want to store our data dynamically. There we can use the link. Okay, so instead of actually array, we can use linked list. The same structure, but the difference is continuous and non-continuous manner. Okay, so any other questions? Okay, which type of linked list is mostly used? Okay, majorly the doubly linked list is used, doubly, because we can traverse in both the direction. Doubly linked list. Depends on actually data also, depend on what type of data and what is the amount of data you are going to store and what frequently you need that data. So that is also is the one of the key aspect, that which kind of linked list you are using for your application. If you require the frequent uses of your data, then majorly the doubly linked list is used. But suppose you are only storing that data, but reading that data you are doing in a somewhat in a month, once in a month, or once in a week, then we can store that data in a single linked list also. So application to application actually it varies. Okay, so we'll discuss about some certification program that is available with GBsoft. Okay, so very first certification program is the programming in C. So where you are starting with the very basics of C language up to the structure and the file handling. And then the second one is the programming in C++. And the third one is the Python programming. Third is the Python programming. And the fourth one is your embedded programming. Embedded programming using Arduino. And the third one is the advanced embedded programming using Raspberry. Okay, so these are the actually programs that is available with us. The fee of the programming in C is actually I'm taking the 5,000 rupees, 4,999. For C++, again, I'm taking 5,000. For Python programming, I'm taking 5,000. For embedded programming using Arduino, I'm taking 2,000. And for advanced programming, I'm taking the 4,000. Okay, but actually, as your college has done the MOU with me, MOU with our company, then they actually, you can get the all certification with a half rate. Okay, in half rate actually you are getting the certification. If you have already done the C++ Python program with me, then you can go for this second or third one also, embedded program using Arduino and the advanced embedded program using Raspberry Pi. Yes, so any question in this certification program? Yes, any question?
No, sir.
Okay, so have you done with the attendance? Everyone done with the attendance? Okay, so anyone who wants to join with this certification program after this, you can contact through your madam or through your HOD sir. Okay, Sanju Sharma sir.
Yes, sir. If anyone is interested, they will contact me or Gayatri ma'am, and we can get in touch with you again.
Yes.
The session was really good, sir. Very informative for our students. From the basics, everything has been told thoroughly. Any questions, any doubts you are having, students, you can always approach sir. He has also already sent his YouTube channel link. Please get subscribed. Any other queries related to this topic, always welcome. You can post your queries to me. We'll get back to you. All the students, mark your attendance in the Google form shared in the chat box. Thank you, sir, for your time.
Yes, sir. Thank
And
you.
uh, we appreciate whatever content was delivered with very patiently. And students also, I hope students have enjoyed listening to you today.
Yeah.
Thank you so much.
Yes, thank you.
See you tomorrow, students. The session will be ending shortly now. Thank you all.